Hello, everyone. So I'm Dr. Furness. I am one of the teaching faculty here at Mines, and the goal of this video is to go through the blue dye calculations part 2. You have been provided a worksheet that takes you step by step through it, but this is just an additional video, an additional resource for you to go through it. So I am going to go through the calculations using Excel to do most of the math for me, and I'll show you how to do all of the setup for that. I do think it makes it a lot easier. You then don't have to do the calculations by hand, which essentially reduces risk of error. I'll also go through how to generate the calibration curve using Excel. The best way to go about this. So let me share my screen. We are looking at Excel. And so what I did is I kind of set up this format, and this is something that I would recommend doing. I have the stock concentration, so this will be different depending on whatever quad you were in. So the stock that I just made up these numbers so that way no one can just use these numbers. This is the stock that I'll be assuming. And then this should look very similar to the Blue Dye Lab worksheet, results worksheet that you're expected to turn in. So if you'll notice, it looks very similar to this, where I have the columns listed across. So the solution name, volume of the blue dye, etc. And so I'll go back to my Excel worksheet. The solution name, volume of the stock blue dye solution used. So this was the amount of blue dye that you added to your volumetric flasks. The concentration of the blue dye in the calibration solutions. This is something we'll have to calculate, which is why I have it blank right now. The measured percent transmittance. So this is what the UV vis or the spectrophotometer was reading out to you, and then calculated absorbance. So again, this is something that we'll have to calculate, and I'll show you how to do that. Underneath here is where I have then the unknown trials. So for part 1, you would have done this exact same thing. For part 2, we now have these 3 additional samples with our unknowns. So just for sake of consistency, I kept the volume used the same in the same column here. So we were using 20 milliliters. So again, taking 20 milliliters of that unknown solution that was in the specimen sample vial that you were given, 20 mils of that. We don't know the concentration of the blue dye because we don't know what the concentration is. It's unknown, so that's why I left this column blank. We then have the measured percent transmittance. So again, this is the value that the LabQuest was spitting out at you. We will calculate the absorbance. We'll then need to use our calibration curve, which I'll show you how to get, to find the equation of the line. We'll be able to calculate this, the dilution factor, and then this will give us the actual concentration in our unknown. So let's go ahead and get started. So what I like to do is use formulas in Excel because then it'll calculate it for me. The first thing that we'll need to calculate is the concentration of the blue dye in the calibration solutions. So because we took some of our original blue dye stock solution and diluted it, this is sounding a lot like a C1V1 equals C2V2 or M1V1 equals M2V2, whichever version you prefer, where I'm having to dilute it. So for this column to calculate, what I'm going to do is I'll type in equals, and then M1 would be my stock concentration. So in this case, M1 is this cell right here. Just to avoid any type of issue with Excel, I'm just going to type in the actual value. So 0.0667, that's M1, times, and then V1 is going to be the volume of that sample that I added. So this time I'll click on this cell, and then M1 V1 equals, and then divided by, so we'll take that whole thing. Oops. Sorry. Let's put this extra parenthesis in here. Divided by V2. And so when we diluted it, the size of the volumetric flask that we were using were 200 milliliters. So divided by 200, and then that will give us the concentration in the individual flasks. So a quick trick here is I can then take this, so if I select this cell where as my equation, and then this little corner right here with this green square, if I pull it down, it now applies that formula to all of the various volumes. So if I click on this cell, now you'll see it's taking M1 V1, but now my V1 would be 2 mils divided by the 200, so divided by V2. Another example, if we just click on this one, for example, so if I take M1, right, again, my stock concentration, V1, so this time it would be 15 mils divided by the 200. So this is why I say I like to set this up. You could, of course, do all of these M1, V1 calculations by hand, but if you plug it into Excel, it'll automatically do it for you. Okay, the next thing that we'll need to calculate is the absorbance. So if we look at the blue dye part 1 packet, this has all of the background on spectroscopy in it. And if I scroll down to page 4, it gives me the conversion or the formula to convert between absorbance and percent transmittance. So absorbance is equal to the negative log of percent transmittance divided by 100. So I can use this formula to and plug it into my Excel spreadsheet so it'll calculate all of the absorbances for me. So that's what we'll do next. So we then say that this is equal to, because we want the absorbance is equal to, and then it was -1 times the log, and we want log base 10 here, times, and then it's transmittance over 100, right? And this time for transmittance, we're selecting whatever is in our transmittance column, hit enter, and then again, we'll do the same thing and drag this down. So now I have all of my absorbance values, okay? Couple of things to keep in mind while we're doing this. You want to be aware of your significant figures. So our volume of the blue dye solution has 2 decimal points because we used volumetric pipettes, and those volumetric pipettes go to the hundredths place. Our stock solution has 3 significant figures, so that was what was given to us, that was what was represented. So we need to assume that we can have 3 significant figures here. When we're doing M1 V1 equals M2 V2, that is multiplication and division, which means we can have the lowest number of sig figs. In that case, it would be 3, okay? If you notice, this one has 3, this has 4, so 3 compared to 4, we can only have 3. So if I look at these values here, they should only have 3 significant figures. So keep that in mind when you're recording those in your actual data sheet. Same thing over here with our percent transmittance. Calculate our percent transmittance, the value that is given to us from Veneer from the LabQuest is 3 significant figures or 1 decimal point, which tells me then that my calculated absorbance can also only have 3 significant figures, okay? So then what I would do, if you want just to keep your sig fig straight, is we can then take our concentration. So I'm just going to transcribe it over here so that way we can get the correct number of sig figs. So 0.000667, that one has 3, 0.00166, and then this would round to 67, 0.0033, and then that would round to a 4, 0.00500, oops, 0.00667. Okay, and I forgot to, so let's do this. Inserts. I forgot to leave the blank here, which would be 0. Okay. So those are all of our concentration values and with the correct number of sig figs, and then our absorbance values would be 3, 4, 3, 5, because we can have 3 of them. 0, 8, 7, 2, and then 0.223, 0.441, 674 and 0.896. Okay, so there's also a reason why I transcribed these over here. Now I have concentration and absorbance. Notice I have it in an X and a Y format. So what I can do is I can select this data, and then I will go to Insert right here in the middle. So it might look a little bit different depending on the version of Excel that you have, or if you're trying to do this on your iPad. In the middle here, you'll see a scatter plot. So I like to drop down. You want the scatter plot without the lines connected, or without the dots connected. We'll add a trend line, but for now, when we're just plotting it, we want it like this. So I plot my data, and here is my scatter plot. Looks pretty good, looks relatively linear for now. Again, I have concentration on the x-axis, and I have absorbance on the y-axis, which is how I want it set up. A couple of things. We want to add a chart title to this, and it should say like calibration curve for blue dye standards, or something to that effect, okay? We also want to make sure that our calibration curve has the axes labeled. The easiest way to go about doing this is to go here. So when the chart is selected, this option will come up, Add Chart Element. If you drop down, you can then say primary horizontal, and then Add Chart Element, primary vertical. Now we have our axes titles. So our y-axis is absorbance. And absorbance doesn't really have any units, but we could put ABS. And then this would be concentration. And you always want to include the units, grams per liter. Okay. So next, what we need is, now that we have our calibration curve, we actually need to get the equation of the line. Remember, the entire point of generating this is then we have a standard curve, which will allow us to then determine the concentration of an unknown given the absorbance value, which is what we kind of did in the second part. So then what you'll do is we'll, again, select our chart. The easiest way to do this is go back over here to Add Chart Element, and then Trend Line. Select Linear Trend Line, okay? And then that includes it. What other things we need, though, is we need to then select the trend line, or you can go back to Chart Element, Trend Line, More Trend Line Options. By selecting that, it'll give us this formatting option for the trend line. We still want to leave it as linear, but towards the bottom here, it says Display Equation on Chart. We want to select that, and then Display R² value on chart. We want to select that as well. So now I have my equation of the best fit line and my R² value. My R² value for this is 0.9999, which is really good. So that kind of passes what our standard would be for linearity, which means I am able to use this calibration curve. All right, now I have my equation of my chart, or equation of my line, excuse me. If you go back to your blue dye results worksheet, if you'll notice, there's a spot right here to include the equation of the line. Again, make sure that you're watching your significant figures though. So remember, we said for our concentration, we could only have 3 sig figs, and for our absorbance, we can have 3 sig figs. So when you're reporting your equation of the line, you need to make sure that that is also correct. Okay, now that I have my equation of my line, I can look at my unknowns and analyze them. So we have our measured absorbance. We can do the same thing then to determine the measured transmittance, excuse me. We can do the same thing to determine our calculated absorbance. So our calculated absorbance, just like we did up here, is going to be equal to -1 times the log base 10 of our transmittance divided by 100. right? We can then drag this down so we get the calculated absorbance for all 3 trials. What I like to do at this moment is kind of take a look and see, does this make sense? So are my calculated absorbances falling for my unknown, falling within the calculated absorbances for my calibration curve? And yes, they are. So my calculated absorbance is 0.298, which means it falls right about the middle. Typically, when you're doing this type of experiment, that's what you would want to see. You would want your unknowns to be within the calibration curve. So again, we can now use our line equation and plug this in. So what do we know? If we know that y equals mx plus b, we then know that absorbance is equal to, the slope is going to be 134.21 times concentration minus or plus b, right? So it could be a negative b, which is fine. 0.0004. Okay, I can use this formula then to rearrange it to solve for x, right? This time I know absorbance. I determined it experimentally by using the UV vis, so I can rearrange this equation to solve for x, or in this case, concentration. So then that means I would have absorbance plus 0.0004, and then all of that divided by 134.21. Okay, and this would then be equal to my concentration. So let's plug this in quick. So we'll say this is equal to absorbance. Well, my absorbance is this value right here, plus 0.0004 divided by my slope, 0.21, enter, and then this would be my reported concentration for the diluted sample, okay? Then the next thing that we need to do is we need to account for the dilution factor. So because we took 20 milliliters of the unknown stock solution and diluted that to 200 milliliters, the actual concentration would then have some dilution factor associated with it. So to, again, use the Excel spreadsheet to do the math for us, what we can say is that the dilution factor is essentially however much we diluted it by, the 200 divided by the amount that we added. So divided by the 20, which ends up being 10. And so essentially all of our solutions were diluted by a factor of 10. So then to get the actual concentration of the original unknown sample, we would then say, well, it would be, this is equal to the diluted concentration times the dilution factor. And so our unknown original sample solution concentration would be these values. I did 3 separate trials, so then we want to take an average. So then we can go to this cell here and say is equal to the average of our 3 trials. And so then this would be the average that we have. So one last thing that I want to do is I want to show you, or go to the actual data sheet. So this is what you should be submitting and turning in, where you have your name, the date that you submitted it, your TA name, and then your specific lab section. So make sure that you're actually including your unique lab section. This can be found in Trailhead. So keep in mind, in Canvas, you are all grouped into the LAB section, but you have a unique lab section. So that's the reason why I put LAC as an example here, just so that way you know that it's not supposed to be LAB. So if you can't find this, go to Trailhead and that's where you'll find it. We include our stock solution, our stock concentration that was given to us. This should be recorded to my 3 significant figures because that's what was listed on the bottle. So we can't have anything more than what we know. If you look here, I've already kind of started the process. So I'll zoom in a little bit just so it's easier for me to write. So here's where we would have our 2.00 mils. Remember, these will all have 2 decimal points because of the pipettes that we use. So this was 5.00, 10.00, 15, and 20. The concentration of the blue dye, this is what we use. So now we have, how many sig figs can this column have? Our stock concentration has 3 significant figures, and our volumes have anywhere from 3 to 4 significant figures. We're doing multiplication here and division, which means we can only have a max of 3. So if I look at my Excel sheet that I had, the calculated, let's see, concentration, so this would be 0.000667, 0.00167, 0.00334, 0.00500. So we have to still include those 2 zeros to keep the correct number of sig figs. 0.0667. All right, going over to calculated absorbance. Now again, we can have 3 significant figures here. So just for sake of not boring you, I won't write them all out, but this would be 0.123435. All right, again, these would be my 3 sig figs. So calculated absorbance, because our measured transmittance all has 3, and our our measured transmittance all has 3 sig figs. That means that our calculated absorbance can only have 3 sig figs. For the equation of the plot of the line, our absorbance values have 3 sig figs here, and our concentrations have 3 sig figs, which tells me then that in my y equals mx plus b formula, my m can only have 3 sig figs, and my b can only have 3 sig figs. So when you're writing out your equation right there, and so I'll write it out just so that way you can see it. Absorbance, so absorbance is equal to, and mine was 134.21, which means I can only include 134 times the concentration, and then minus 0.123, and then I would have 400. Right, so those would be my 3 significant figures for both my slope and B. All right, down here, very similar. So we would have our 20.00 all the way down. So our measured transmittance, what was it? 50.4, 50.4. So the 3 significant figures that come from the vernier, that means my calculated absorbance can only have 3 sig figs. And then the calculated concentration from the equation as well can only have 3. So looking at my spreadsheet, this would then be 0.00222, 0.00222, and 0.00221. All right, dilution factor, the number of sig figs for that doesn't really matter. And then for the concentration of the unknown, this would also have to be only 3. So 0.0222, 22, and 0.0221. All right, make sure that you include your unknown number and then what the average is down here. So my average was 0.0222, and this would be grams per liter. Okay, so that's kind of the quick way of doing the calculations using Excel. Again, you don't necessarily have to use Excel. You could use Google Sheets or Numbers or whatever other kind of spreadsheet data analysis software that you like, but you do need to make sure that you're including all of these values. And then everything needs to be transcribed to the data sheet, and that's what should be submitted. So if you have any questions on this, also keep in mind the numbers that I used are all example numbers. They were made up values. They were an average of a couple of different scores. So please, please, please do not use my values. Use the values that you actually obtained. So if you have any questions, don't hesitate to reach out to either me or your TAs. So thanks, guys.